So which one of the following mineral has isolated tetrahedral? So you know isolated tetrahedral that belongs to mesosilica structure, among which olivine is mesosilica structure, and they are linked by divalent cation Mg and Fe. So olivine. Among the following, the mineral showing acicular habit. Acicular is a needle-like habit. So sillimanite it is so acicular habit. Cyanide it is so bladed. Sillimanite so acicular. The correct order of stability of silica polymorphs with increasing of pressure. If we increase the pressure, what will be the correct order of the silica polymorphs? It is an MSQ question. The quartz, coesite, stishovite. So this is the silica polymorphs diagram where these are the pressure variety. So after quartz you will get coesite and stishovite. After quartz you will get coesite and stishovite. So this option will be correct. Quartz, coesite, stishovite. Obviously this will be incorrect because stishovite is more or higher pressure than coesite. Coesite, stishovite will be also correct. You can see in this figure. Tridymite, then coesite, then stishovite. So this option will be correct. So A and C will be correct. Which of the following statement is correct? An isotropic mineral remains dark to 360-degree rotation of stage under cross-nickel. Because isotropics are completely dark under cross-nickel condition, so if you rotate the stage, it will remain as dark. That is correct. Leucolysis is the change of color of a mineral during rotation under cross-polar. It is during rotation under PPL, so it will be incorrect. Minerals of triclinic system are optically uniaxial. It is incorrect because triclinic system belongs to biaxial. Melatop in an interference figure marks the emergence of optic axis. So this is correct because optic axis that represented by melatop in the interference figure. So option A and D will be correct. So the following statement is correct for the upper hemisphere stereographic position. So here this is your A axis, this is B axis, the center is C axis. So that's why the angle between them are also here 90 degree. So from that you can see alpha, beta, gamma is 90 degree. Crystal contain one tetrad. Tetra means one four-fold axis. So it has one four-fold axis that represented the C axis. Crystal contain four dyads on a two-fold axis. So this is one, this is two along axial, and another two along diagonal. So there are four dyads or two-fold axis. Crystal contains five mirror planes. You see, these are our four mirror planes and the circle. This is another mirror plane. So total we have five mirror planes. So all the option will be correct. Next up to 2019 question. So polymorphic minerals have. So what is a polymorphs? So when we say polymorphs, it has different, you can say, crystal form, but same chemical composition. So polymorphs, it is characterized by different crystal form, but same chemical composition. So take the example of calcium carbonate, calcite aragonite, calcite hexagonal, aragonite orthorhombic. So mineral with different crystal form but identical composition, they are called as polymorphs. Then the stereo position given below represents it. So the stereo position given below here, it is represents 6 bar. So 6 bar, it is equal to 3 by m. So the name of 6 bar is trigonal dipyramid. Answer will be trigonal dipyramid. So which of the following exhibits the optic interference figure given below? See, this is the optic interference figure of an uniaxial mineral. Among this, which is uniaxial, that will show this type of figure. So quartz, it belongs to hexagonal system, it is uniaxial. Diapside, it is biaxial because diapside is monoclinic system. Orthoclase, it is monoclinic. So both diapside and orthoclase will be biaxial. Garnet is isotropic. So this interface figure, it belongs to uniaxial. So quartz will show this type of interface figure. Match the mineral groups 1 with 2. The labradorite, then actinolite, chlorite, barite. Barite you have encountered two times. Then this is third time. So barite, it has high specific gravity. There is only one option here where we see so barite is high specific gravity. So that will be the answer. But you can check the other. Labradorite. Labradorite, it's so clear color, that is called the labradescence. Then actinolite, it has acicular habit. Then fluorite, it's 4 sets of cleavage. Fluorite, diamond, stelite, they also 4 sets of cleavage. Answer will be C. So which one of the following defines a hexagonal dipyramid? So what is an hexagonal dipyramid? As a symbol 6 by M. 6 by M. So hexagonal dipyramid, it is 6 by M belongs to hexagonal system. So what it indicates? Hexagonal dipyramid. Let's analyze the option. A vertical 6-fold axis of symmetry. Obviously, in case of hexagonal system, then hexagonal dipyramid that has a 6-fold axis of symmetry. But hexagonal dipyramid also has a mirror plane, so only a vertical 6-fold axis will not be enough. A horizontal mirror plane, obviously a horizontal mirror plane is there. Then 6, but it is not completely explaining 6 by M. 6 vertical mirror planes at angle 30 degree to each other, completely incorrect. The only option left, a mirror plane that is perpendicular to the vertical 6-fold axis. So you can see this will be the diagram. 6 by M. So the C axis is the 6-fold axis, and this is the mirror plane that perpendicular to the C-fold axis. So 6-fold axis perpendicular to mirror plane. The answer will be D. The mineral sequence arranged in order of increasing of degree of shearing of SI of tetrahedral. The question repeat again, but this time instead of the silicate structure, given the examples. So same we have to follow the nesosilicate, that is olivine here. It's so 0 shearing. Then enstatite, it is orthopyroxene, belongs to your single chain, so it will share 2. Then tremolite, it is amphibole, it will share 3, or you can say 2. Then quartz, it will share 4. So this will be the increasing order, correct increasing order, that is olivine, enstatite, then tremolite, then quartz. Next question, we have to compare these twinning and their examples. So cross-hatch twinning, it is a characteristic of microcline. Then Carlsbad, it is a characteristic of orthoclase, say Sedimentary, to the polymorphs of orthoclase. Then polysynthetic or lamellar twinning, it is a characteristic of plagioclase. Then Brazil, it is quartz. So cross-hatch microcline, P will be 2, Carlsbad, Sedimentary, Q will be 3, R1 is 4. P2, Q, 3, R1 is 4. B option. Then comes to another MSQ question. Under cross polar, a mineral remains dark at all stages of rotation of the microscopic stage. Under cross polar, if the mineral remains dark at all stages, then you can see it is it belongs to isotropic isometric system, and it will be isotropic. So the mineral is isotropic, it will be correct. The mineral is biaxial with an optic orientation correspond to the principal section of the indicatrix. So if you take a principal section of the indicatrix, okay, then it will not become isotropic. It will not become isotropic. So that's why in biaxial there is no such orientation where the mineral will dark at all stages. The mineral is biaxial with an optic orientation containing the y vibration direction. It will also incorrect. The mineral is uniaxial with an orientation perpendicular to the optic axis, because the mineral with a in case of uniaxial mineral, if you take a section perpendicular to the optic axis, it will become isotropic. So the basal section, or you can say section perpendicular to the optic axis, is isotropic in case of uniaxial. So A and D will be correct.